Hello, we are Group 46 and for our project we decided to take on the Soapbox Challenge. Since it was a fun and interesting way to further our skills and knowledge of the subject and engineering as a whole. We are a team of 3 people, Jacob our coordinator, which is me, James the team worker and Josh our specialist. In the following video we will show the process of our work and the method behind our final prototype design. Regulations for Red Bull Challenge are available online. However, it is not running this year, so we decided to use the regulations for the wacky races, aiming to enter this competition in May this year.
Initially, we studied designs entered into previous Soapbox events, paying close attention to their strengths and weaknesses. We decided that our theme should be plastic waste in the oceans and the harm it does to sea life, which is in line with the university's ethos on sustainability. In addition to this, all structural components are to be made from salvaged materials. Further into development, we designed steering mechanisms in SolidWorks, producing a number of MDF prototypes to best evaluate the individual systems.
Our chassis designs all feature a triangulated steel bar layout for improved strength and crumple capabilities. We later added a roll cage to improve driver safety. The regulations for wacky races require the driver's eye to be 700mm from the road surface, so we adjusted our design accordingly. The rest of our final design was formed around this chassis structure.
Our final design is 2.3 meters long, 1.2 meters wide and 1 meter high. The chassis alone weighs 52 kilograms according to CAD, and the Soapbox is estimated to be below 80 kilograms when complete. As the regulations require the 700mm eye height, we allowed for a more upright seating position than previously outlined. They also require brakes on 2 wheels, so our rear wheels are fitted with salvaged disc brakes.
Our front wheels will be salvaged from mopeds and have the suspension taken from old quad bikes, attached to VW wheel hubs, each with both VW and Mercedes wishbone components attaching it to the chassis. The steering mechanism features a plate attached to a horizontal steering column, acting on track rods linked to each wheel hub. The skin of the vehicle will be formed from strips of woven plastic taken from bottles found on the beach and other public spaces.
Through this process, we have developed teamworking skills and furthered our CAD knowledge along with our practical skills such as MIG welding and grinding. If we did this again, we would like to run more tests and calculations to optimise velocity through weight distribution, overall mass and aerodynamics. One thing we would like to have done as well was testing the drag in a wind tunnel to calculate the maximum true velocities.
Thank you for listening.